expect it to repeat in the future. Right? So if you don't make the data correction, what's happening is you come up with an incorrect forecast. If you make the data correction, then you come up with a decent forecast. This is just using the stat model. You kind of identify, flag the outlier, boom, it comes up with the right forecast. Most tools have an inbuilt outlier detection process. Right? SAP does too. Right? There is an inbuilt outlier detection process. JDA does, Oracle does, Forecast Pro, will show you. There's an inbuilt outlier detection process. So basically, you look at a statistical threshold. You define a stat threshold to say, hey, if it is off 10, 25% plus or minus, can I let that go? If it crosses that plus or minus 25% band, then I'm going to look at it whether its data is extreme or not. So normal data, extreme data. If it is extreme, I'm going to look at whether it's system error or not, or legitimate data. If it is legitimate, then I'm going to see if it is repeatable or non-repeatable. If it is repeatable, right, then it's an event. If there is an extraordinary extreme observation, either high or low, that's repeatable, then it's an event. So which means you need to get data about the event in the future. Right? It could be a promotion, Super Bowl, whatever. Yeah.
People software, is it standard deviation? How is that calculated and what kind of threshold do people utilize?
It uses standard deviation, so we don't talk about that.
We will talk about that later.
Absolutely.
Now, when do you decide whether or not you eliminate the outlier or you adjust the outlier? Because eliminating an outlier can create a gap or missing in the data, whether you adjust it based on some other factor. Is there a rule that tells you, well, in certain cases you might adjust the outlier, in other cases you might just get rid of it altogether?
Right. So most cases, best practice is to address the outlier, not to get rid of it. Right. So basically, you need to come up with a strategy to replace the outlier with something.
All right. So an adjustment to the outlier.
Exactly. You don't want to just throw it away and make it zero,
Okay.
or make it missing data.
Yeah.
Right. Because that's going to be an outlier on its own.
Exactly.
What's the, and maybe you're going to get into this, but what's the best process for doing that? Do you just take the 20 and knock it down to 10, or do you
We'll talk about that.
Okay.
We'll talk about that, right? So if it is non-repeatable, right? If it is non-repeatable, that's an outlier that you want to correct. Now, correct doesn't mean throwing away, right? Correct means replacing it with something reasonable that's within the distribution, right? Because if you just throw it away and make it zero, that's going to be an extreme also, right? Compared to the average volume, right? So what we do is we establish what is called as a tolerance band around the exposed forecast. So if you have data, right, and if you just come up with this green line, which is an exposed forecast. Remember, what is an exposed forecast? Forecasting the history. It's a best fit of all the scatter points, right? So you have scatter points, you come up with this. And then you say, I'm going to kind of build a road around it, a confidence band, right? And that depends on what your K factor is, how many K factors you use. And you could use model error, you could use standard deviation. You could say, I'm going to use standard deviations. How many standard deviations am I going to use? 1, 2, 3. That's the K factor. If I use 3 standard deviations, a very rigorous test, right? In normal distribution, going back to high school stats, average plus or minus 1 standard deviation covers how many observations? What percent of the distribution? Anyone? 60, 65%, 66%, right? 66% of the data points. So if you have 36 months of observations, 66%, 2/3 is how much? 24. So average plus or minus standard deviation should generally cover 24 of the data points. If you have 3 years worth of data. 3 standard deviations would cover how many observations? Almost 95, 96%. So which means it should really cover 33, 34 observations, right? So if you're using 3 standard deviations and then you look at it, that would potentially qualify as an outlier, right? And that's how you determine it. It's your first test. So really, you look at where the scatter is, right? And then say, if your data point is here, it is an outlier if you're using 1 standard deviation. It is not an outlier if you're using 2 standard deviations, right? So the K factor determines how many observations are thrown out from the data. Typically, it is replaced, the data is replaced with either the average or the exposed forecast. Forecast for that particular month. Model fit. Right? So basically, if your K factor or the number of standard deviations is low, it will flag many outliers. If K is high, if you're using 5 standard deviations, 6 standard deviations, you'll never find an outlier, right? Almost everything is good. Because the band is so large, right? Almost anything goes, right? So if you use a very high K factor, then everything goes, right? So basically, typically, best practice is to replace it with the exposed forecast, meaning the modeled forecast for that particular month, which incorporates both trend and seasonality, right? Because if you just replace it with average, what will happen? It may not be the right thing, right? Because average is a flat thing, right? Flat over the entire period. So, an average, if you replace this with an average, where would the average be? Probably below, right? So you actually go and look at the exposed forecast. Once again, I know this may be a lot within the 3 hours, right? Exposed forecast, are you all comfortable with exposed forecast? Definition of exposed forecast? Yes, anyone? Still having a little trouble? Exposed forecast is defined early on, right? What slide number? Exposed forecast in 13, right? Page 13 of the book. Exposed forecast is the forecasting the history or the model fit number, right? Model fit, how best the model fits your scatter pattern, right? So basically, I think that's kind of like how you create outliers. So the thing that we need to know in terms of outliers is, okay, if your K factor is smaller, you throw away many observations. You throw away many observations, right? So, and that happens often, right? It's a very little check, right? And people who probably implement the software don't know. Especially if they hard-code a number. If you use a K factor of 1, what may happen is, it'll throw away all seasonal points. High season, low season, high season, low season, everything is gone. Right? Because they're all away from the average, right? So what will you get? The model takes the rest. What will be the resulting model forecast? A flat line, exactly, right? Because the K of 1, a low sigma, has thrown away all seasonal points, right? All seasonal points. So there is an entry on my blog, forecastingblog.com, if you need more reading material, especially tonight. And if you want to get good sleep, read my blog entry. Go to bed, lie down, read this blog entry, you're out. So there is a blog entry on this specific issue. Why do statistical engines create flat forecasts? Right? So, maybe we can just take a look at the graph at least. So I think that's a good time to break for lunch, right? And thank you for being patient on a long session. So we will be going to, there's a ballroom, right?
Yeah, we're going to the Tiffany Ballroom, and I can show you how to get there. So just follow me down there.
Okay. Follow me.
Yeah, I'll be back.
We gotta